Okay, so just like you said, since we kind of like speeding through it at the end there, I don't know why that integral is like over here by itself. But anyways, what we had done is we had found the area of the center portion of the graph, but what we were missing was, oh, nope, not that. We were missing this like extra portion on both sides in here, and so that's what we had to go do. And since they appeared to be equal, we really only needed to do one of them. I think we actually ended up doing both of them. No, we did. We just multiplied it by 2. So we had to do, and it changed which one was on the top and the bottom in the parameters of it, but we ended up finding the area of one of them, specifically the one on the left for this problem, and then multiplied it by 2, and then added it to the area from the middle piece that was up there. So the total area was 8. Let's see. Let's start with this one. All right, 22. We have x equals y squared, and we have x equals y plus 2. Now, in terms of graphing this, obviously, again, like our method of just plugging in points would still work, but for the sake of time, let's just use our calculator. I mean, I think y'all can sufficiently plug points in. So, can we, however, plug in x equals y squared? No. So what do you think we might need to do?
Get y by itself.
Get y by itself.
So do we have to do that with both of them?
There's another way that you can do this, that where you actually say, since they're both equal to x, you can say y squared is equal to y plus 2, and like do something that way, but I think that's harder. Like I would just do it this way of solving for y. So we're going to have y equals the square root of x, and y equals x minus 2. And so those now are two things that I think you would be able to pretty well graph on your own. I mean, you know what the parent function of a square root function looks like, and the other one is literally just a line. But like I said, for the sake of time, we'll just do this on here. And make sure you do Zoom 6. Now, what do you notice about this graph that's different than the other ones?
There's one intersection. Both graphs are exponential.
Not exponential.
I mean, like, growing.
There's no enclosed.
Right. There's no enclosed area because there's only one intersection point. But what do we know about the square root function?
That it goes to infinity.
It can't be negative, right? Yes, it also goes to infinity. But in terms of what we can see, so I'm going to zoom box this area right in here so I can see that. So I've got about that region right there. So I'm looking for this area in here because it can't be down here. The domain doesn't exist down here. So when I'm looking, I'm going to have to be looking from 0 to whatever this intersection point is. So remember, to do that, we do second trace, intersect. You just need to be on one of the lines, and then on the other one, doesn't really matter where. So my intersection is at x equals 4.
Wait, where did you? I missed the first.
Just anywhere on this graph, it really doesn't matter where.
Okay.
Just anywhere on that graph and anywhere on this one, since it only intersects in one place.
Oh,
It only
okay.
mattered yesterday for the ones we were doing because it intersected in multiple areas. So that's why we had to be, had to check and be more careful. But this one, one of them has to be on one graph, one has to be on the other. I usually try to get semi-close to it, but
Can you repeat that? Sorry, I was trying to figure something out on my calculator. So where's the trace function?
second, we'll trace it at the top. And then intersect is what you're looking for. It should be option 5.
And then where do we select on that?
You need one on the square root graph and then one on the line.
Okay. It doesn't matter
It should
where.
automatically.
Yeah, once you select one line, it should automatically jump you to the other line or
Okay.
the other function, depending on the problem.
Okay.
So then it says that our intersection is at 4, 2, so x equals 4. So our interval is going to be from 0 to 4. And which one is on top in this situation? Of the intersection area, which one's on top?
Oh.
The,
What? X equals y plus 2.
X minus 2.
Yeah. Y equals x minus
So the top is going to be this one.
The top, yeah.
'Cause this is under
Y
this
equals
one.
root x.
Oh, okay. Oh,
Yeah.
you're just talking. Okay.
So this is going to be f of x, this is going to be g of x. I'm just labeling them this way so that you have that with in regards to the formula that we've had. So now I can set this up. It's the integral from 0 to 4 of the square root of x. I'm actually going to write this as x to the 1/2 for the sake of integrating it in a minute. Minus, I'm going to go ahead and just change, since this is only one thing, I'm going to write this as minus x plus 2 instead of having to, write out the parentheses. Like that.
Wait, how's it supposed to?
Because it would be, the normal formula is minus g of x. This is g of x, so I did minus x plus. I just went ahead and distributed the negative.
Quick question: why is the interval 0 to 4 again if x was equal to 4?
Because that's where the enclosed region ends.
Oh.
So I'm finding the area of that enclosed region.
Oh, that makes sense. Yeah.
Basically what's happening is I'm finding the area under here, but that area keeps going. But this line, by cutting it there and subtracting this off, removes this excess area over here that I don't need, is what we're essentially doing with this formula. Is we could just find the whole area under the one function, but I need to subtract off the other part to find the enclosed region. So, how do I integrate this?
2/3 x to the 3/2.
One half x squared plus 2x.
And evaluated from 0 to 4. Obviously, the 0 piece, everything's just going to be 0, but for the 4 piece, I've got to do it. So, this is going to be 2/3, 4 to the 3/2 minus 1/2, 4 squared, plus 2 times 4. So, what's 4 to the 3/2?
Oh, wait, oh.
8.
Oh.
Okay, so take the square root of 4, which is 2, cube it, which is 8, and then it'll be times 2 over 3, so that'll end up being 16 over 3.
I forgot that's how that
4 squared is 16, divided by 2 is 8, so minus 8 plus 8. We might have to do one more thing. Hold on. No, that's it. Okay. All right, then. Let's see. 24. X minus y squared equals 0, and x plus 2y squared equals 3. I'm actually going to do this one a little different than normal. We're going to get x by itself on this one. Because sometimes on the exam, they're going to have x by itself. Like x is going to be equal to something, and you're going to need to be able to do it with respect to y. So we'll do it that way because there's a different way to find the parameters for y ones. So I'll show you
Can we
that.
still do that on the calculator? Or is that like have to be done by hand?
You probably won't need to.
Okay.
If it's X.
It's probably going to be pretty obvious which way it should be. We'll see. Yeah, we'll see. But it should still work. All right, so this is going to be x is equal to y squared. This is going to be x is equal to negative 2y squared plus 3. So to find the parameters, we'll do that first, and then we'll determine which one should be like our, well, f of y and g of y. So which one's top and bottom. I am going to set them equal to each other. So we're going to do this one by setting them equal to each other and solving them that way. So we're going to have y squared is equal to negative 2y squared plus 3. Solve for y. Or, yep, so this is going to be 3y squared equals 3, y squared equals 1, so y equals plus or minus 1. And that's going to be your parameters. So we just solved for your parameters on that. And technically, I think x can be done the same way. I'd have to go back and check one, but you could do the same thing by setting the y equations equal to each other. Like when it says y equals whatever, Like you could set those equal to each other and find them the same way. Yeah, if you didn't have your calculator.
So you could find the parameters
Without graphing it.
okay.
The only thing is if you don't know what the graphs look like, it's going to be hard to know which one's supposed to be top and bottom.
Oh, okay. That makes sense.
But if they gave it to you on a non-calculator portion, that would be how you would have to find the parameters of it. If it's something that's like a harder one. All right, so I'm going to end up with the integral from -1 to 1. But I need to determine which of these graphs is on the top and which one is on the bottom, or I guess it's technically left and right, because it'll be like this, right? Because we're with respect to y instead of x. Because what do these look like?
A parabola and a linear equation. Wait, never mind. Both are
Both are parabolas. And so the general one would be like, to y'all, like this. Okay, it'll be on the right side of the graph. The other one would be on the left. So, which one do you think goes on the right and which one do you think goes on the
I think the y
left?
squared goes on the right. Negative 2y squared doesn't go on the left
Why do you think that?
because the y squared is positive.
Yeah, so this one is negative and it shifted. So this is going to be something like, roughly, something like this. And something like that. Obviously not perfect, but something like that. And so I'm finding this area in here from -1 to 1. So it's going to be this one minus this one. Yeah. So -2y squared plus 3 minus y squared.
So that's our f of x right there.
Well, this would be f of
F of
y, and this would be g of y.
Oh, so we go left to right, is how we do
Yeah,
it.
left minus right, top minus bottom.
Okay.
Yeah, I'm just thinking like positive or whatever.
Yeah.
So I've got the integral from -1 to 1 of -3y squared plus 3 dy, and I need to integrate that. So it's nice and easy.
That one is -y cubed. Plus 3y.
And evaluated from -1 to 1. If I plug in 1, I get -1 plus 3 minus -1 plugged in there is going to end up giving me a +1. -1 plugged in here is going to give me a -3. So I've got 2 minus a -2, which is plus, so area is going to be 4.
Cool.
26, we're going to get y by itself, and we're going to try to find the parameters by hand for x this time instead of using the calculator. We may still have to use it to figure out where the graph is going, but 26, they give us 4x squared plus y equals 4, and x to the 4th minus y equals 1.
You said we're getting what by itself?
We're going to get y by itself so that we can do what we did up here with finding the parameters for y with x by hand. Because this is the last one like this that we're going to do. So I figure it would be good to see one by hand. Alright, so I'm going to have y equals -4x squared plus 4. Over here I've got -y equals -x to the 4th plus 1. Divide by the negative, y equals x to the 4th minus 1. Now, without even having to look at the graph, what do you know to be true about the first one?
It's a parabola.
Negative.
Meaning it goes what way?
Down.
Opens down, so it's going to be like this. Okay, what do you know about the other one?
It opens up.
And usually these graphs look like a W, so it's going to be opened up like this. Okay, so you're going to have a W and a parabola. So, I'm going to set these two things equal to each other. So I'm going to have x negative 4x squared plus 4 is equal to x to the 4th minus 1. So I'm going to move these things over. I'm just going to move them to the left. So actually I'm going to move it to the right because I want positive stuff. 0 equals x to the 4th plus 4x squared minus 5. Yeah. Now what do I need to do with it? What does this look like? I need to factor it, right? Because it still has the form kind of like what we normally have when we have an x squared, an x, and a constant. This just has an x to the 4th, an x squared, and a constant. So how might I factor this?
You could find like factors of 5 that add up to 4.
Which would be what?
1. Negative 1, yeah, negative 1, 5.
Negative 1 and 5. So this is going to be, but notice because this was x to the 4th, it's going to be x squared plus 5 and x squared minus 1. And remember, my mom had to do this in Algebra 1 the other day. There is no reason to ever get factoring wrong. If you think you did it wrong or you're not 100% confident that you would have done it right, FOIL it back. You should never get it wrong. But for some reason in her class, they never want to check their work. And then they get mad when they don't do well. She's like, if you would have just checked it, you would have known your signs were backwards. Anyways, little rant for the day. So now what?
Each piece equals 0.
Yep, each piece equal to 0. So I'm going to have x squared plus 5 equals 0. X squared minus 1 equals 0. What happens to this one?
Well, you have a negative under the radical, so like
Yep, x is going to be equal to plus or minus the square root of negative 5, right? So that right there is a what?
a
Does not work.
A red flag. Can't have that. Get rid of it.
Irrational.
Yep, it's going to have an I. Can't have that. So we can just throw it out. So that means that automatically is going to be removed from my parameters. Okay? So then over here, what do I have?
What did you say?
What?
Yeah, sure. Plus or minus 1. So I'm going to have that my area is the integral from negative 1 to 1. I just realized I haven't been writing the A equals, but I think y'all know we're solving for
Yeah.
area, so.
Yeah. I was wondering, I was like, wait, is this different now? Then I was like, oh, wait, yeah.
No, same
We
thing.
just haven't been
That's right.
writing
I
A.
forgot we were solving for.
All right, so
We also haven't put, like, it's not like there's units to do, so, like.
true. All right, so because I said I know what this graph looks like, which one's going to be the one that's on top or the one that's listed first? The negative one. So it's going to be negative 4x squared plus 4. And then it's going to be minus this piece. Again, just to save writing a step, I'm going to go ahead and distribute that. So minus x to the 4th plus 1.
Why is the negative 1 first?
Because
Because it's the one that opens down.
the other one's the W.
And then the W's like this. The W's opening up.
So our W is
And I'm making an assumption that it's a W because that's pretty often what the 4th power ones are. But sometimes they look a little more like a U than a W.
So our
But either way,
W
it's going to be opening up because
our-
it's
like
positive.
Our W equation is G of X.
Yes. So yeah, so this would have been our g of x here, and this is f of x. And then obviously dx on the whole thing. So the integral from -1 to 1 of negative x to the 4th minus 4x squared plus 5 dx. Integrate that. And what do I get? Minus.
Four
4/3
thirds
x to the third
cubed.
plus 5.
Yep. And evaluated from -1 to 1. So we do the 1 first. So that's going to be, if I plug in 1, I have -1/5 minus 4/3 plus 5 minus, plug in -1, I get 1/5 plus 4/3 minus 5. Right, somebody check and make sure my signs are all right.
Yeah.
Okay. So then I've got -1/5 minus 1/5, so that's going to be -2/5. -4/3 minus 4/3, -8/3. 5 minus -5, so that's plus 10. Get them all over 15, I guess. So that's going to be -6 over 15 minus 40 over 15 plus 150 over 15. Yeah. What was that? 104 over 15.
Will they ask for a fraction on the exam or a decimal?
The book has it as a mixed number actually, but I mean, if it's on the calculator section, they might have it as a decimal. But I mean, it's not going to be fill in the blank unless it's.
Okay.
Now, I say that, and then the only way you're going to have to be the one to actually write it out is if it's in a short answer question, which could potentially happen. And I think they would take it either way unless they specify one way or the other. But I also don't think they can really expect you to take the time to write that as a decimal. Like, yes, you could do that. But I don't think they can really expect you to do it as a decimal when it's on a non-calculator portion, because that's just going to take you too long. Like, that's not proving that you know calculus, which is the goal of the exam.
You know, like 6.
Yeah.
Will we have to deal with imaginary numbers on the AP Calc exam? Because
I mean, we could. 'Cause it might be
Maybe,
stuff that, like,
but
they assume you know, but like.
there's a lot of like prereqs to this that they assume you know. Like in pre-cal, one of the prereqs is knowing law of sines and law of cosines
Really?
to that exam. Yeah. But like our book teaches it. So like I actually taught it. They are saying you should have already known this coming in, like I shouldn't have to reteach it is what they're saying.
Oh, wow.
So some of that they're just going to assume you should already know.
When was the last time we actually...
I don't know if I can find a prereq sheet for this class of like the things that you should already know, I'll give it to you, but I don't know that the book has
You don't know
one,
what to do.
because it's going to say anything that you should have known in calculus you should also know for this.
Yeah. What do we do with imaginary
Where
numbers?
does -1?
Oh, that's the one, I -1, -I1. Is that what it was? I have no idea what that corresponds to.
I -1, -I1.
I -1.
It's I squared, I cubed, I to the 4th. I -1, -I1.
Yeah, Could you check
All
and
I
see if
know
that's
are
like
the
a
eyes.
prerequisite?
It probably is, because that's
I'm not
definitely
trying to get-
something you should know from like algebra 2.
Yeah, that's like, we haven't done problems with imaginary numbers in like.
All right, I'm going to do one more trig problem for you, just because they might be cruel on the exam, so I feel like you should probably see this.
So mean. These are.
These problems are taking up entire pages.
Now, on this one, the beauty of it is you don't have to find the parameters. Why?
They give you
Trey.
them.
They already gave them to us. Nice and easy.
Okay. Well, wait. When did you write that down?
Yeah, I didn't see the 0 less than or equal to.
I wrote it when I wrote the rest of the problem.
Yeah.
I don't remember that.
Memories.
Wait, is that chi or is that x?
Really?
That's X. Chi squared is in stats.
Yeah, but that looks like a chi to me.
They all look the same. Like what?
No, because doesn't chi only have a curl on it? Like, and an x. It looks like a x. but
My
it's
X's always look like this.
Yeah.
Mhm.
My X's have always and forever looked like
Whoa,
that.
I just realized.
Well, you just asked me what
Yeah, because we're learning about chi squared stats. You would know, remember?
it's all redundant.
That might have been one of those that we like had to speed through because it was the end of the year. All right, now this is a prereq. What's another way I can write sine 2x? It's a double angle formula.
Yeah.
Might want to look over
Double
those.
angle is pre-rad.
Wait.
All trig identities are prereqs to
Everything
this.
we learned pre to this class.
Is
It's
needed for this
Wait, what's
class.
a double angle?
Nah, if there's double angles or half angles on
That's like
there.
the one thing in trig that I would
Sine of 2x is a double angle.
Yeah. There's like formulas.
What do you
like
mean,
The
what's
one
a double
formula and the half
Ethan,
angle
please
formula.
help.
No, I asked Ethan, he said he didn't even know what it was.
I mean, I know.
How about, does any of this ring a bell?
No.
No. Wait, kinda, but I
Well, I
forgot.
think double and half were like the
Oh.
ones we kind of like
Like
skimmed
I
over.
remember it.
I remember-
we
this
didn't
was
do anything
pre-calculus.
with them last year, really, though.
No.
Well, right, I'm not asking you to do something with them. I'm just asking you to rewrite the formula.
Yeah.
You might want to memorize these before the exam. I would suggest when we're done today, you take a picture of this paper.
See, I had the excuse because I learned it in 10th grade. That was too long ago.
We did them last year in college algebra too. Are you sure?
So much.
It's,
I think you did because I thought.
no, like,
Mike was
see,
complaining
I
about it.
remember this now, but.
Probably.
I
I remember she would always do her homework in here.
Yes, every day. All right, so this is going to be rewritten as y equals.
2 sine x cosine.
There we go. You're also going to need to know the unit circle. So
Yeah,
if
I
you
know.
forgot that, I
That-
would suggest you refresh
Well,
your
that-
memory.
That was on the nose.
That's
Like
like
I
it
knew
is.
that one.
This was like under
going
the
into
carpet.
it, like,
Under the carpet.
yeah, this
Under
is-
the rug.
we need to like take the dust off.
This was definitely swept under the rug.
These are pretty dusty.
So, any ideas?
So-
we want to graph it
oh,
and see what
we
it looks
could-
like.
Oh, okay, okay.
Yeah, I probably should. Because
'Cause I'm not
Now,
supposed to-
this one is the basic parent function of sine,
Yeah.
but an amplitude of 2. So it's really this other one that we need to see what it looks like.
Okay.
And you're going to want to use Zoom Trig when you finish this. Yeah, and make sure you put parentheses around the sine x piece so it's not cosine in the sine because it's not the same thing. Zoom 7. So the first thing it's graphing is your 2 sine of x. Now it's graphing 2 sine x cosine
It
x.
looks cool.
oh,
There's a lot of intersections.
it's
so.
like it had no bank.
It looks
Right, but I only care about what?
I
The
don't know.
parameter.
Oh,
Which
the
is
yeah,
0 to
the
pi.
ones in the parameter.
So all I really care about is going to be this, probably 1 right here. Now, which one's on top?
Oh,
Oh,
right.
The big one.
the sign. Wait.
The
rest-
big
oh,
one.
gosh.
No, 2 sine x is on top.
Yes. It's like, what do you mean the big one?
Yeah.
We're not at Talladega, like, easy.
You don't know that either? No?
Alright, the integral from 0 to pi of 2 sine x minus 2 sine x cosine x dx. Now, I need to integrate this lovely thing here.
Oh, no.
Any idea what I might need to do
Use substitution.
eventually, but I need to do something first.
Oh.
You need a
You
factor.
could
How?
take out.
You're right, I just
Take
want to know
out
how.
a
Take out two
two
sign.
sign X.
Yep, take out a 2 sin x. I'm going to go as far as to put the 2 out front of the integral because it's just going to be constant. So 0 to pi of sine of x times 1 minus cosine x. Now, u substitution, what should u be?
1 minus
1 minus cosine x. Did you sneeze so hard that the calculator went flying?
Yeah.
All right, so what's du?
Du.
Oh goodness.
Oh, wasn't that a?
Sin x.
Sine x.
dx.
So sine x dx.
We have that.
So now, look at that. I have everything. It's so exciting.
That's
Right.
crazy.
Right? Because sine x is here, dx, 1 minus cosine. So I have 2 integral from 0 to pi of u du. What's the integral of u?
1/2 u squared.
1/2 u squared. So the 2 and the 1/2 are going to cancel. Right? We see that?
Yes.
2, 1/2 canceling. So all I have is u squared from 0 to pi. But what do I need to do first?
Plug in your thing.
Plug in your
1 minus cosine, yep. So 1 minus cosine x. And that whole thing is squared. So when you get your number for that, you got to square the whole thing from 0 to pi. What is the cosine of pi? -1 times the negative, so that's going to become positive, plus 1, so that's going to be 1 squared minus, when I plug in 0, what's the cosine of 0? 1. Am I missing something here? Oh, y'all don't need any more cookie points. That's why you're not saying anything.
We're not saying anything because we don't see it.
I see it.
What is
Oh,
it?
yeah.
We plug in
Be
du.
1 plus 1.
From where?
1 minus -1 is 2.
Yeah. This should be 2 squared.
I just never say anything. I'm the quiet guy.
See,
No, 'cause, like,
the
I
issue
just-
is that we don't know.
I just low-key,
Sometimes
like,
it
trusted
actually
you.
does help
Wait,
when
I'm
you
still
have
listening,
saved
I guess,
Oh,
write it.
Well, I
Jesus,
just
what
told
type
him
of
I
cookies are we
was
gonna
lining
get?
up. It's not lying.
Whatever y'all want. All right, and then minus, when we plug in that 1 minus 1 is 0, so this ends up being 4.
Man, all of that.
I mean, it could have been worse.
Honestly, the first one would be the worst.
The first trig one. I think too, like I think if you went back and did the first one again, you wouldn't think it's as bad. But
Yeah.
because that's where we started, it seemed miserable.
Yeah.
Okay, problems are 3, 5, 7. Getting there. 15, 17.
First one was 2.
And then 25 and 29. And just to be clear, on your quiz, which will probably be Thursday, just because of timing, I'm not going to give you a picture of the graph. Okay, so the problems that have the pictures with them, you're not going to be given one with the graph. Now, the picture is kind of just like if you use your calculator to do it. I'm going to let you use your calculator on the quiz, but I would advise when you do some of these for homework that you do attempt to do them by hand so that if it was on a no calculator portion, you'd know what to do. So I'll let you do it either way on the quiz, but I am going to let you have a calculator because for the most part, you do have a calculator. So,
The quiz is 8.1 and 8.2.
yes.